I said I would send you another example from class, so let's do another one. 1 over x cubed plus 2x squared plus x dx. When I look at this, the first thing I cannot do is an easy integral, the second thing is substitution, and the third is parts. So the next thing we can do is consider partial fractions, because this doesn't have any trig in it. So we set up our decomposition. 1 over x cubed plus 2x squared plus x. I see that all the terms have an x, so I can factor that out. So I've got 1 over x times x squared plus 2x plus 1 underneath a 1. And that right term can factor, so I get 1 over x times x plus 1 squared. Since I've got the x plus 1 squared, it repeats. That's going to mean I need a little more room here. So my decomposition will be 1 over x cubed plus 2x squared plus x is actually equal to a over x plus b over x plus 1 plus c over x plus 1 squared. In order to get the decomposition, in order to start solving for the constants, we need to multiply. We're going to multiply through by the factored form. It's easier to see what's going on. So our left-hand side becomes 1, and our right-hand side becomes a times x plus 1 squared, because a has an x underneath it, so that cancels with the x, and the x plus 1 sticks around. Then a plus b times x plus 1. Then plus c times x, because the x plus 1 squared both cancels. After we've multiplied, we want to start solving, so we plug in some roots. In order to plug in some roots, we're going to plug in x equals 0 first. The other root I see is negative 1. So x equals 0, our left-hand side is a 1. Our right-hand side, anything with an x is going to cancel, so those two terms go away. So we've got a times 0 plus 1 squared. Well, that's just a 1 squared, so that's just an a. So we already know a. The next root we can plug in is negative 1. So we'll plug in on the left side, it's still just a 1. On the right side, anything with an x plus 1 will cancel, so our only term left is the c. c times negative 1. That tells us that c is equal to negative 1. So we now know a and c. After we've done both roots, we have to update our function. So our left-hand side stays a 1. We're updating from before we plugged anything in. Our right-hand side becomes 1 times x plus 1 squared plus b times x plus 1 minus x, because our c was a negative 1. Now we plug in anything that's not a root. Now I say anything, you just pick something easy, non-root. I'm going to plug in x equals positive 1. The left-hand side is still boring. 1. The right-hand side becomes 1 plus 1 squared plus b times 1 plus 1 minus 1. That's being plugged in. When you add this 1 to both sides, you'll get 2 equals 2 squared plus b times 2. When you subtract the 4 from both sides, you'll get negative 2 equals 2b. So b has to equal negative 1 when you divide both sides by 2. So that gives us a and b and c. So our original integral, 1 over x cubed plus 2x squared plus x dx, becomes the integral of 1 over x, because a was a 1, minus, because b is a negative 1, the integral of 1 over x plus 1 dx. I should have a dx with each of these. Minus the integral of 1 over x plus 1 squared dx. So I've just taken my 3 from above and split them up into separate integrals. The first one is easy. That's natural log absolute value x. The second one is easy-ish. That's natural log absolute value x plus 1. You could do a substitution to find it. The third one, you could use substitution where u is x plus 1 to see that it's just a power rule. So that would be u to the negative 2, which becomes negative u to the negative 1. So You could say that this is your final answer, or you could simplify your natural logs using pre-cal and say that this is the natural log of x over x plus 1 plus 1 over x plus 1 plus c. That might appear more often in a real-world setting, the natural log of x over x plus 1, but either answer would be perfectly acceptable for what we want.